we're going to work a little bit more with adding and subtracting. So first off, let's take this one and look at what we need to get our common denominator. So if I factor that, since it's different squares, into x plus 5 and x minus 5, my least common multiple is going to have both of those factors and also my factor of x plus 3 from my second fraction. So if I write this out and multiply by whatever it takes to get all three of those factors in my denominator, it's going to look like this. Because I need in my first rational expression the missing factor of x plus 3, so I'll multiply by x plus 3 over x plus 3. And in my second one, I need both the factors of x plus 5 and x minus 5. So if I do that multiplication by my missing factors, I will have a common denominator, and I can write it as a single fraction, which is going to look like this. And then I need to do some simplifying. So on top, I actually need to do my operations so that I can simplify and combine like terms. I need to multiply first before I subtract. So if I multiply my x plus 3's times each other, I get x squared plus 3x plus 3x plus 9. And then I already had my x minus 5 and x plus 5 as x squared minus 25 from earlier. And I'm just going to distribute my 3. So then I can go ahead and put those 3 x's together, and I'm going to erase that in between step. That's going to be my numerator, simplified slightly, still over that same denominator. Now that I've done my multiplication, I can go ahead and add my like terms together. So I'll have negative 2x squared plus 6x plus 84 all over my denominator. Remember, we should check and see if the top factors, in case we might be able to factor or divide out a common factor. So I'm going to pull out a negative 2 from the top and then think about what that leaves me with. Now, if I factor that negative 2 out, I need numbers that multiply to negative 42 and add up to negative 3. 6 and 7 doesn't work. There aren't any numbers that will do that, so that's as simplified as I can go. Now we're going to work with some rational expressions that are called complex fractions, which, sounds exciting because they're complex, but don't worry, they're actually not too bad if you take them one piece at a time. So take the top part and the bottom part separately. I'm going to start with the top. So my top is 6 over x minus 5 plus 1 over x. Now, if I think about my least common denominator, I'll need each of those factors, so I'm going to multiply the first one by x over x and the second one by x minus 5 over x minus 5. And then I'll have 6x over x times x minus 5 minus just x minus 5 over x minus 5. I can go ahead and put them as a single fraction since they have a common denominator, so I've got my plus in between, and then all over my denominator of x times x minus 5. If I add my like terms together on top, I'll get 7x minus 5 over that same denominator. Now I'm just going to leave that one for the moment. We're going to work on the bottom. Same idea. So I'm going to do my 3 over x minus 2 over x minus 5 by multiplying to get a common denominator. And then I'll be able to actually write it as a single fraction. If I distribute my 3 to my x minus 5, I'll have 3x minus 15 and then minus my 2x, and I can combine some like terms to end up with x minus 15 over x times x minus 5. Now remember, that was like the top and the bottom, and those two things are being divided. So what I'm really looking at is I rewrote the numerator and denominator, and I have those two new fractions being divided. So if I'm dividing fractions, I need to multiply by the reciprocal. So I'm going to flip my bottom and then multiply it times what I had on top. Don't actually distribute everything, because if you look, you have some common factors that you can divide out to 1. The x minus 5s and the x are going to divide out to 1, and you'll just have 7x minus 5 over x minus 15. Let's look at one more of these complex fractions. So again, work with the top and bottom separately. If I'm simplifying on top, I'm going to go ahead and need to multiply by x over x on my 4 over 1. And then I'll be able to actually write it as a single fraction. There weren't any like terms to combine. I'm going to do the same thing on my denominator, multiply by x over x, and then I can turn it into 2 plus 3x over x. Don't forget that I was really dividing those two things, so I'm going to take my top one, leave it, and then multiply by the reciprocal of my denominator. Now, if you look, you can divide your x's out to 1, and you're just going to end up with 2 minus 4x over 2 plus 3x. And there are no common factors between all of those, so you are done.